Alright, time for another DraftPhysics.com video presentation. So, Toady has responded in comment, which is very nice to see again, to one of the 5-minute videos I did showing the Newton's cradle using the uneven masses, and there is no analysis by anybody of measuring the actual movement of anything or approximating it as best they can anyway in terms of the gravitational arc without knowing the distances of the strings and all that kind of stuff. Kind of not possible to do from this camera angle, but anyway, just demonstrating that Newton's cradles, I'm just saying we can all know, I think we can all deduce that they don't produce this extra momentum effect. I mean, if they did, then that's how they would demonstrate it. They wouldn't be doing air tracks and carts and all this other stuff when they could just do it easily with a Newton's cradle. And Newton would have observed it, or Descartes. I'm sure Descartes banged plenty of things, pendulums into pendulums. I mean, he did a ton of collision experiments. So I don't think that Newton's cradle, although it's, named after Newton, I think you could argue that it might even have been a Galilean, something he even did to some extent. So anyway, so he responded to that video, and so I'll read his comment. There's a little history here, so I guess I have to explain some things. Alright, even though I've been exorcised to the outer darkness, I don't think that happened, okay? I mean, all I did was react to the fact that, all of my opponents currently are easily identified as assholes. I mean, their tactics are obviously cheaty and slimy and in every way disreputable. I mean, it's not the kind of thing people with any kind of integrity or character use as tactics. That is, publishing images of my house and my family and then doxing me routinely. This isn't something nice people do. Alright. Or people who just have a really great argument and want to make their really great argument. Okay. All of the jump cuts, all of the, the chicanery done around every single argument they make contains these lies and nonsense. And the fact that you couldn't recognize that and thought that this is some sort of like you're going to stand in the middle and be a clean person. Okay, no, there's just no way. You have to pick a side, so to speak, and in my opinion, you picked the wrong side in terms of having conversation with those wads of scum. That's it, okay? I mean, I didn't sanction you in any way. I didn't block you. I didn't do anything. So, frankly, I like your contribution. I like the fact that you're interested. And I have referenced your experiment, 5 or 6 times in pointing out that, you did the collision between two uneven masses, okay, with the same momentum but different kinetic energies, and you proved anyway that we know that kinetic energy doesn't move collisions. So although momentum does, whatever happens in a collision, if something has more momentum than the other object, it moves the collision. The whole collision moves with a thing with more momentum. And the fact is that's a demonstration that momentum is real and kinetic energy isn't, because the thing with more kinetic energy doesn't move the collision. Alright, anyway, this is an interesting video. It would be nice to see Michael's response to this. Yes, that's what I've encouraged, but see, Michael doesn't respond directly to me. Frankly, he just, even though we had the one conversation, I mean, I can't really get him to answer my questions in any kind of direct manner, and I can't inspire him through suggestion, okay, to pay attention, to counter-argue. I'd just like to hear him counter-argue the gravitational argument. I mean, that's the first argument that needs clarification. Where did 9.8 meters per second come from? I mean, it's not Newtonian. It's not even. Okay, the fact is, it's not really even Leibnizian. But anyway, it would nice to see Michael's response to this, as it seems the kinetic energy is being created and destroyed each impact. Well, the theoretical kinetic energy, right? Because the fact is, the experiment, I don't think, shows any kinetic energy at all. It doesn't show that this ball comes in and gives this one, 1.5 in this case, because it's a 3 times the mass, that it gives it 1.5, the momentum. There's no evidence of that. So again, it's, this experiment doesn't show it. So, you know, there's the thing they have to respond to is why it doesn't work in a Newton's cradle. And if it does, why the hell in 300 and plus years has nobody shown how Newton's cradles make a free momentum? Through using the Lewin approach, perhaps I should be deducting the reverse direction from the outer to retain the 100 value. Well, of course, that's what I pointed out, that yes, it works if you just pretend. So you pretend it makes extra energy, and then the big ball comes back with its extra momentum, okay, and it turns back into just the regular 100 again. So it has 150 going in, and it's only 100 going back out again. So it creates free momentum or extra momentum, and then somehow destroys the extra momentum. I mean, it doesn't make any sense, frankly. The very idea, okay, that an explosion creates zero momentum is nonsensical. It shouldn't even be something I have to debate. This idea that because there's a left component and there's a right component, that somehow they're opposite each other and they cancel in some way. There's no canceling momentum. It's just an idiotic notion. I throw a wrench into space from China, or, well, Fuji, and I throw a wrench into space from, North America, and somehow they cancel each other. I know they don't. If they hit a Martian somewhere, that the Martian didn't get really hit because I hit a Vulcan, with the other wrench. Come on, it's ridiculous. All right, would be truly wonderful would be to see this undertaken using carts. So I don't know why that's what we want to do, but anyway. And then I think it'd be truly wonderful for somebody just to measure it on a Newton's cradle, do the measurements. Somebody with one of these high-speed cameras can do really good imaging. No problem. And then have one of the carts impact another cart down the track. So yes, the idea of capitalizing on this free thing and multiplying it more than once would be an interesting experiment to see. Now, Brozo attempted it, he didn't get anywhere, so he couldn't make it happen. But clearly, if all you have to do is increase the mass and just keep banging lighter things into heavier things, and you can keep making free momentum, that obviously sounds suspiciously stupid. So it really does, even though they don't feel like they have any obligation to explain, they really have an obligation to explain. I mean, it sounds suspiciously stupid. I mean, realistically, what do you mean? You think you can just keep doubling the momentum? And that's what you could do. So if you go from a 1 mass to a 5 mass, I think mathematically you're already at the point where you're almost doubling the momentum. So if you double the mass, it's 33%. If you triple the mass, it's 55%, right? If you quadruple the mass, then it would be 75%, and you would assume at a 5 mass, a 5 to 1 ratio, you're getting a full doubling of the mass, of the momentum with each collision. We know the cart's speed plus mass, it's 3 times the initial 1 mass cart. This would finally put the whole debate to bed. Well, I don't know if that's what it would do with carts, but I'm just saying, I think the Newton's cradle would. All right, I mean, if you can make a Newton's cradle do this nonsense of making free momentum, and it's so much easier to do, just because you can put the increasing masses in order fairly easy. and just have them cascade and just see what your big heavy thing at the end does. All Michael would need to do is impact the 3 mass with a 1 mass cart, measuring the velocity and showing the results KE values. So yeah, well, I already suggested you use a heavier, he only did the 2-to-1 relationship, and I suggested do the heavier one, do the 1-to-3 or the 1-to-4 or the 1-to-5, and let's see if we get this, doubling of the momentum. Perhaps you could ask Michael. Now, see, this is the part where you go wrong again. I mean, obviously, I'm not able to get much out of Michael. Okay, it's just he is doing the lever experiment. All right, but even that, it's been 19 days or whatever, and there's been no communication about progress or what's going on much, except that any day now maybe. Anyway. To use his setup to undertake this test, which Lewin did without clay fairly. Obviously, it needs to be done well, and I don't know if carts, okay, that is sort of a step down. Now, the air track, as I've pointed out, is a little bit suspicious also because there is a source of free energy. So at least with carts, there's no anti-friction device that's being created by adding energy to the system. So there's less, it's more isolated as a system. So there's less chance of something creating the extra energy. Only been waiting a year or so. Yeah, well, I've been waiting a lot longer. Would truly like to see the results. No advantage give actual velocity values at set points. No averages, sorry. Yes, even those accusations, you can't, everything's taken personally and all this other stuff. But I mean, yes, in the one video, it seemed clear he was using averages. Yeah. And he's done some of these experiments. Again, he did this experiment. I mean, I'll illustrate it. And, and you're just saying on its face, is this not worthy of some explanation? I mean, where's the logic in it? How can this be a fact? And how can it be a fact that nobody's noticed? Not as far as I've seen. I can find no physicist, I can find no paper or no conversation about the fact that, we already have the capacity to derive any kind of amount of energy we want out of an explosion. So we can have an explosion that is a spring expansion, and we have exactly the same, compression of a spring, let's call it, and we put 1 mass carts, and then we put 2 mass carts. Now this is the context that he did the Lewin experiment in. So he did the Lewin experiment, where he did the 1 into the 2, the bastardization of this experiment, in the same context they did these 2 experiments. So it sort of gives you some reason to wonder why his results for the Lewin experiment were correct, is because these results are not sensible. Anyway, so this is what he gets, right? So these things come out with a certain momentum. We'll just say, for the sake of argument, we'll just use 100 because it's an easy number, and we get 200 here. All right, and this implies this way, and it implies this way. So the idea is that I got 400 total momentums here, and I only have 200 here. So the same spring compression created different momentums. That's the evidence. That's the proof he did. He proved, that you can make virtually any amount of momentum, because you could just take this relationship and you just extrapolate it, And so, if you use 3 masses, you could get, that would be 303, so that'd be 600, and then I could use 4s, I get 800, and, I could just keep going this way, and I can keep going this way, in the sense that I put a 50 in front, and I'm going to get 100, and I can put 25, and I'm going to get 50, and so somehow the momentum of a system And momentum is supposed to be indestructible. I mean, frankly, I think they agree that you can't destroy momentum. So where did it go? In these different experiments, what happened to the momentum? Because you have to say that it must have this maximum. So whatever the maximum would be, right? So I don't know. How big could I go? And they'll claim that a brick wall, okay, that I can throw something at a brick wall and I can put two momentums inside of it. And I get one momentum back. Let's just say 100, just to give realistic numbers. Okay, I put 200 into the brick wall, and they claim it went in there. They say it's there, that there's somehow momentum, even though there's zero velocity. Okay, somehow it's in there. So in this context, how do you make any sense out of that? I mean, you got to know there's got to be some kind of defect, some sort of. Well, maybe it's because the cart is built in. It's got a little, by Arbor Scientific, they put a 14-cent spring in the device. Okay, it's this little cheap, shitty spring. Maybe that has something to do with the explosion making different momentums. That might be, okay. Oh, I'm just guessing though. That might be the cause of the effect. And really, there is no different amount of momentum. I mean, we know the little explosion, in theory, is just made out of little pieces. So we know that we can't really change the momentum of the explosion because it's already made out of momentum. The force has already been converted into the momentum of little bits of crap. The little bits of crap can only transfer their momentum. So it has to go somewhere. But yeah, it is all very tedious, and the effort has been to create some sort of experiment that's just undeniable and so simple that nobody could screw it up, and that there can't be any flaw in it. And in some respects, I think we have a taste of that. I mean, Mythbusters crashed cars into brick walls. That seemed pretty good evidence. I mean, it was clearly just 2 to 1. I mean, you double the speed, you just double the amount of crushing of the car. There's no evidence of 4 times the crushing. So that's a pretty good experiment. Their clay experiment, although imperfect in terms of how they measured it and performed it even, clearly also wasn't showing any great sign of kinetic energy. It was pretty much showing momentum being consistent. Brozo's little billiard ball experiment, pretty much showing momentum works. So there's pieces. Ian Gosling, just dropping weights on Play-Doh and seeing how much energy is displayed, in the collector. The Play-Doh is the collector of the energy. What it does is telling you how much energy the thing had, the event. That experiment came out proving momentum. Can't show it to you because he hid it from you, right? The honest players that you would, you sort of were giving way too much benefit of the doubt to, hid the experiment. Anyway. Alright, so we'll move on to another comment that gets more to the more fundamental question, which is, how do you people even believe what the whole structure they have built this out of? Again, I have gone over the history so many times, and nobody thinks that history is a substantial argument in and of itself. The very fact that this is not Newtonian physics, that Newton overtly stated how he thinks the second law works, which is clearly all momentum. The force essentially makes momentum, and momentum makes the force. I mean, he saw a huge equality. You want to go twice as fast, you apply twice the force. You want to go 3 times as fast, you apply 3 times the force, not 9 times the force. Clearly. But whatever. Alright, before we move on, so just to Toady, I mean, I'm glad to see you back. You probably should, direct your questions directly to physicist Michael, and he may respond, to you. because I can't get much out of them. So I'm just saying, maybe you should give it a try. Yeah. All right, so here's a comment on the website message board. You still can't understand how acceleration is denoted. I think I'm pointing out how it's just nonsense. Yes, I'm saying what you're doing is nonsense. It doesn't make any rational sense. It isn't in any way connected to anything real. It's just mushy jargon. Okay, it doesn't have anything to do with velocity or acceleration. It's yeah, it's not a foreign language. It's no language. It's not bad math. It's non-math. Okay, you just can't get past your ability to grasp that. Yes, that's right. I can't get past my inability to pretend I think nonsense makes sense. It's right. Nonsense doesn't make sense. So 9.8 meters per second, which is Newton's formula, okay, it's per 1 second. It's not per any number of seconds. It's not per a half second or 2 seconds or 20 seconds. It's per 1 single second. It's a velocity, yes. Okay, just like you go 60 miles per 1 hour. Okay, if somebody says I'm going 60 miles per hours, you would say, what do you mean, hours? You know, and you certainly couldn't say 1 hour squared, because that would be stupid. So you can't understand that your jargon is nonsense. Absolute, proven nonsense. It can't make any sense. If you applied it to any other circumstance, you would be laughed at as an imbecile. So go ahead and walk up to somebody and say, I'm going to go 60 miles per hour in my car. Or I'm going to go 60 miles per hour squared in my car. Go ahead. Say that. All right. And then he says 9.8 meters per second squared is acceleration. Because that's what we said. That somehow the rate, it's a rate of acceleration is somehow something different, okay, than a rate of velocity. When no, it's just a change in velocity. So yes, it's the same exact thing. You have a rate of changing your velocity, and it's the same as the rate that was your velocity. So you can say you're going to go 60 miles an hour, but I'm going to decelerate at a rate of 4 miles an hour. That's what you could say, and it would make perfectly good sense. And it would be, one rate would be in 1 hour, and the other rate would be in 1 hour. So again, what you're talking is gibberish. All you've done is type this little 2 sentences and said, there, can't you understand my argument? No, I can't understand your argument because it's junk. It's nonsense. It's gibberish. It's crap. Okay, it's not reasonable. And so let's just do it again. I mean, I get to again and again and again and again and again and again until somebody responds to it, until somebody plays the clip and explains, like a Piro, explains how it's not a time-dependent force, that it isn't, Newton didn't say 9.8 over 1 second. That's the rate, okay? That's the proven fact, okay? We've proven this one. We've dropped things. Galileo did it. We've dropped them. We've measured it. That's the rate that this stuff falls. Okay, so we know that it gets that velocity. Now we know that as you drop something, it has to increase its velocity. But that's the final what you're going to get after 1 second. So after 1 second, it'll be traveling 9.8. It will have traveled a distance, okay, of 4.9, because it had to incrementally, exactly the same, by the same rules, by the way. So it incrementally, okay, acquired this velocity, which means that in the first quarter it got half, okay, of that 9.8. So half of the 9.8, 4.4, okay, no, sorry about that, 4.9, okay. of this rate was actually acquired here in this little section, and then it acquired the other 4.9 here. And you can just keep focusing in and doing the same thing, and that's the acceleration. That's how acceleration works. So that's what we found out about acceleration, is that it it's this 1, 3, 5, 7. That's Galileo 500 years ago. All right. So there's nothing special about an acceleration. Acceleration is also a rate. You can't change the seconds. Okay, there's no Newton wouldn't say, yeah, go ahead, put 0.5 here and leave this number the same. Okay, go ahead, put 667 in here seconds and leave that number the same. Newton didn't say that. Nobody says that. You can't do that. It's per 1 unit of time, 1 second of time. And the same is true for the acceleration. So it's just nonsense to say that accelerations are special and somehow you square the 1. And that's what you would have to square, right? You can't square some other number. You can't say this ratio, okay, is the same as 9.8 over 7.6 seconds squared. You can't do that, okay? It's irrational. It's nonsense. It's not math. It's garbage, okay? It's just propaganda for Jesus theory, okay? That's all this is. But anyway. So, and the simple argument is made that, look, you see it, okay? We already know this is how it works, okay? So I drop it 1 unit of distance. It will go 9.8 meters in 1 second. And then if I take it to 4 times the height, okay, it'll do this here. So this will be identical to this. It'll be going 9.8 after 1 second. Okay, and what what Galileo observed is that it'll do this, okay, 3 units of distance in 1 second. Okay, that's all, 1 second. All right, so it'll do 1 unit in, 9.8, and it's only 4.9 in distance, but again, this is 4.9, 4.9, 4.9, so it's 2 seconds total, and its velocity will be exactly what is expected, 19.6. So it lands perfectly, it makes perfect sense. Everything Newton did was sensible, it makes sense, this all adds up nicely. Where, okay, do you think it's possible that something was squared here? So what are you squaring? The 2 seconds? So you're saying it's 9.8 meters per 2 seconds squared? Again, no, it's 9.8 per individual second. And it makes no sense to say that it accelerated some other rate, because it didn't. It only got 2 units of acceleration. It's only gotten 2 units of velocity. How could I accelerate 4 units worth, okay, of 9.8, right? That's what you're saying, okay, and only end up with a velocity of 19.6. How is that possible? How is 4 times 9.8 equal 19.6? The acceleration has to lead to a velocity. So it doesn't exist. So again, it's twice the time, twice the velocity, twice the weight. When you drop it and it lands on a spring, the 4 times is only going to compress the spring twice as much. And yet you're going to tell me it's 4 times the energy. So 2 equals 4. 1 plus 1, okay, equals 4. That's all you're saying. You're not saying anything else. There's no other math necessary here. This is a ratio. You cannot change this bottom part of the ratio without changing this. If you don't do that, then it's not a rational, consistent ratio. Then it's a ratio that somehow changes. There's no changing the ratio. And of course, squaring a 1 is superfluous. So, until somebody explains where I made an error in this description of the reality, I have no reason to get over my inability to grasp your jumbo mumbo blumblo flumblo. Okay, I don't understand where you're imagining this extra was injected. It's 19.6, it's 2 seconds. There's no evidence that there's any source of anything more than just an increase in the velocity. And why would the increase in the velocity contain more of something? Why would I believe a mass gets heavier, in some magical way, besides just velocity? That's it. There's just a mass moving a velocity. Where does that fail in the physical universe? Show me the experiment where analyzing the mass of the object and its velocity will get me a bad answer. Show me that place. Alright. I think that's it. So I'll just check to see if there's anything new and call it a video. Alright, so it looks like that's all there is. So till the next time and such. Good to see your little icon there, Toady. And come again and such. Alright, so till the next time. Blah, 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 blah.